Another way to consider a growth and decay function using base E is given here, and it can be rewritten, and we're not going to go through the derivation of it, but it can be rewritten as y equals PE to the RT. P is the initial amount, R is the instantaneous or continuous growth or decay rate. So we use the word rate. Remember, that's a percent that we're going to change to a decimal. So, we talked about rates before, but we've always had to convert that to a factor. In this formula, we don't. We leave it as a rate. If R is positive, then it's a growth function. If it's negative, then it's an exponential decay function. So in question number 62, and you're like, well, when do we have to use the formula? Use the formula when you see that word continuously. That's your big hint right there, that you're using what I call the PERT formula. How long will it take $25,000, so that's my initial amount, that's P, to grow to $150,000, that's the amount out that I want, that's my output, if invested at 9.3%. Change that to a decimal, move it over 2 places to the left, and we're looking for time. Round to the nearest tenth of a year, so 1 decimal place. So I plug that information into my formula. The output, 150,000, equals 25,000. E, it's a number on my calculator, to the R, 0.093t. It's an exponential, it's hooked by multiplication, so we solve it just like we did before. Divide off by the 25,000 to both sides. All right, so our E to the 0.093t equals, and then go ahead and do the division. Comes up nice number 6. Log base E of 6 equals the power. Log base E is natural log. And then solve for t, so divide both sides by 0.093. Now they wanted a decimal approximation, so we're not going to waste a whole lot of time on the exact answer, but just go right to our calculator. Take natural log of 6, so you're using the ln button now, divided by 0.093. Okay, and to the nearest tenth of a year, it's going to be about 19.3 years. Make sure you put your unit label on there. Similar idea for example 63. How long, so we're looking for t, will it take $15,000 to double? All right, if the rate is 2.36%, so call that 0.0236, 2 places to the left. Compounded continuously reminds me that I'm going to be using my PERT formula. So we're starting with 15,000, that's my P. To double though, I've got to think about that. If I'm doubling 15,000, that's going to be 30,000. That's going to be my output or my Y value that I want. So I go right to the formula. I'm starting with I'm starting my equation with 30,000, but that's what I want out. My initial amount was 15,000. E, the rate 0.0236, and then t is what you're looking for. If you divide both sides by 15,000, your end result on the left is going to be the number 2 because you doubled your amount. E to the 0.0236t. You've got an exponential, so to get rid of that, you use a logarithm. Log base E of 2 equals the power. Remember, you're always setting the logarithm equal to the power. All right. Log base e is natural log. And then solve for t. So you can see they all have about the same method of solving. All right, divide by 0.0236. And again, just go straight to the calculator. All right, so we want natural log of 2 this time, divided by 0.0236. We get about and 1/10 of a year, so 29.4 years this time. Okay. So suppose 5,000 is invested, so that's my initial amount. Compounded continuously indicates that I use the PERT formula as opposed to y equals ca to the x. What interest rate, so we're looking for r this time, will it grow to? This is my output number. In 8 years, that's my time. Round to the nearest percent. All right, so we go to our formula. You plug in your output, $10,544.75. We're starting with $5,000. E to the R, T being 8. Here's my exponential, so I got to get rid of the 5,000. So just do a division step there. Okay. And again, whatever it works out to be, hold all the digits. Oops, too many 4s there. On your calculator. Okay, so 2.10895 equals e to the r times 8, or 8r. Once the exponent's by itself, log base e of that big decimal, 2.10895, equals the power. Log base e is natural log. And then divide both sides by 8. All right, so when I do that, take the natural log of, and I'm going to just do the answer from above. So I'm going to do second and then negate key down here by the enter, the negate key. Just did a copy paste for me so that I don't have to retype that whole decimal in. Divide by 8 and I get 0.09327. All right, but as a percent, all right, I'm going to move the decimal over 2 places. So that's 9.327, bunch of other digits. They want it rounded to the nearest percent. So 9.3, that 3 isn't big enough to bump it up, so 9% is to the nearest percent, or our nearest percent.